Welcome back, everyone. So I know you've all been digging into some fascinating sources lately, all about lunar exploration.
Some really interesting stuff out there.
Yeah, and especially about this new tech. It's called the Electrodynamic Dust Shield.
Ah,
And that's what we're diving deep into today.
it's so cool, right? We're all hyped about going back to the moon.
Absolutely.
But there's this hazard we don't always think about, lunar dust.
It's a big one.
And the thing is, it's not like the dust bunnies we find under our couches. This
Yeah.
stuff is a real problem.
Oh, it is. You see, when we think about dust, we think of it as a minor annoyance, right?
Yeah, just a little bit of a nuisance.
But lunar dust, it's incredibly abrasive.
Oh, wow.
Yeah, one source even compared it to, like, tiny shards of glass.
Whoa, really?
Yeah, and that really gets at the danger it poses to both equipment and astronauts.
Sharp dust on the moon. I have to admit, that never crossed my mind.
It's not something we tend to think about, is it? But it makes sense when you consider the moon's environment.
Well, here on Earth, we have wind and water, right?
Right.
Those elements wear down rough edges over time. But on the moon, no such luck.
Ah, so everything just stays sharp.
Sharp and abrasive and ready to cause all sorts of trouble.
So we're not just talking about dirty spacesuits then. We're talking about damage to sensitive equipment.
Precisely. See, this lunar dust can get into everything. Seals, mechanisms, even habitats.
Really, anywhere.
Oh, yeah. Imagine those tiny glass shards, right? Infiltrating a spacesuit's oxygen system or damaging a solar panel.
That's a scary thought.
Yeah, it's a huge risk to mission success.
And from what I read, it's not just sharp, it's electrostatically charged, too.
Oh, that's right. And that makes it cling to everything. You can't even just brush it off.
Really? You can't even brush it off.
No, that electrostatic charge makes it stick like glue. Any attempts to brush it off, it makes it cling even harder.
Wow. So traditional cleaning methods, those just don't work.
They're practically useless.
Okay, so we've got this nasty, clingy, sharp dust to contend with. And this is where this new technology comes in.
The Electrodynamic Dust Shield.
The EDS. It sounds pretty futuristic to me.
It does have a certain sci-fi ring to it, doesn't it?
It does.
But the science behind it is solid. The EDS, it utilizes transparent electrodes and electric fields.
I see.
And what it does is it creates forces that repel those charged dust particles.
So it's like an invisible force field pushing the dust away.
That's a good way to put it.
And this tech, it can be applied to different services, right? Spacesuits, visors,
Yeah,
solar panels.
Exactly. That's the beauty of it. It's versatile. Can be adapted for a lot of applications. Makes it crucial for protecting both astronauts and equipment.
And it's not just a concept either, is it? This tech is actually being tested on a lunar mission.
The Blue Ghost mission.
That's right, launching on January 15th.
Very soon.
So Firefly Aerospace, they're partnering with NASA's Commercial Lunar Payload Services Initiative. They're sending the Blue Ghost lander to the moon and one of the 10 payloads on board the EDS.
It's going to be really interesting to see how it performs.
Yeah, this is a real-world test in the lunar environment. We're going from laboratory testing to an actual mission.
Big step.
What does this mean for the future of lunar exploration if this technology is successful?
Well, if we can really mitigate the dust problem, it opens up so many possibilities. Longer-lasting equipment, safer conditions for the astronauts.
And what else?
We could even start thinking about, a permanent lunar base.
Oh, wow. It's amazing to think that something as small as dust can have such a major impact on our ability to explore space. Really makes you appreciate the challenges involved in venturing beyond Earth.
Absolutely. This mission really highlights how important innovation and collaboration are when we try to overcome these challenges.
And this is where it gets really interesting. I'm so eager to hear more.
Me too.
Let's dive into the bigger picture implications of EDS.
But it's fascinating to think that the implications of EDS, they extend far beyond just the moon.
Oh, really? What other applications are we looking at?
Well, one place that springs to mind immediately is Mars.
Ah, Mars, of course.
Yeah, Mars is known for these massive planet-wide dust storms, right?
Yes, absolutely.
And that dust, it's a huge threat to robotic missions.
Yeah, makes sense.
And it'd be a major obstacle for future human settlements, too.
Oh, yeah, I can imagine.
If the EDS tech proves successful on the moon, adapting it for Mars could be revolutionary.
You're right. It would be a whole new perspective on things. It's like we're really close to solving a fundamental challenge of space exploration.
Exactly. And you know what's really smart about the EDS? It doesn't just try to shield us from the dust. It actually uses the dust's own properties, that electrostatic charge.
Oh, interesting.
Yeah, it uses it to our advantage. It's like turning a problem into a solution.
That's pretty ingenious. It makes you realize that sometimes the most innovative solutions come from understanding the challenge itself.
Absolutely. And the potential applications, they go even further. Think about like challenging environments here on Earth.
Oh, right here.
Yeah, like deserts, mines, industrial settings, anywhere dust control is really important. And this tech developed for space exploration could have a real impact back here at home.
It's incredible how space exploration can lead to innovations that benefit us in unexpected ways.
Yeah, it really is. Speaks to the power of human ingenuity, right?
Yeah.
Our drive to push the boundaries of what's possible. We're not just going to sit back and accept limitations. We want to overcome them.
And in the process, we discover solutions to all sorts of other problems.
Exactly. So in a way, this small mission to test a dust shield on the moon, it's a giant leap forward in understanding how to deal with challenging environments.
It really is.
The Blue Ghost mission, it's about so much more than testing a dust shield. It's a huge step toward new possibilities for exploration, both in space and here on Earth.
And I bet you'll be watching closely to see how the EDS performs in that harsh lunar environment.
Oh, absolutely. There's so much we can learn from this real-world test. Will it live up to expectations? Will it exceed them?
Right.
The data we get from this mission, it's going to be invaluable.
So exciting to think we're on the verge of these big advancements.
It is.
This is a mission everyone should follow because it could really impact the future of space exploration.
And I think it's so important for everyone to appreciate this kind of research, even if they're not scientists.
Yeah, I agree.
It shows our human potential.
Yeah.
The amazing things we can do when we work together.
You've got a point there. It really goes beyond just the technical stuff. It's about that spirit of exploration, the pursuit of knowledge, realizing that what's possible is constantly changing.
You said it. And who knows what other incredible discoveries are out there as we keep exploring space.
Right.
Maybe one day we'll look back at the EDS and think that was a turning point. The thing that opened up even more amazing achievements.
That's a really inspiring thought. And I, for one, am really eager to keep exploring this topic. What other extreme environments could benefit from this tech? So thinking about how this EDS tech, designed for lunar dust, right, could be used in other extreme environments, what other places could it make a real difference?
Well, one that jumps out at me is underwater exploration.
Underwater. Yeah.
I know, you wouldn't think of it as dusty, would you?
Not really, no.
But think about it. You've got fine sediment that can clog up equipment, mess up visibility. It can even be risky for divers.
That's a great point. I hadn't thought about that.
Yeah, so the ideas behind the EDS could be adapted for underwater use. Imagine like a submersible, right? With a system that repels sediment, keeps the cameras clear, the instruments working properly.
Wow. It could change how we study those delicate ecosystems underwater.
Yeah.
And explore shipwrecks or other underwater sites.
Absolutely. And it's not just about exploring. Think about industries like offshore drilling or underwater construction.
So many applications. It's amazing how a solution for lunar dust could have these like ripple effects across so many fields.
Totally. And it goes back to what we talked about earlier, about the benefits of space exploration that we don't always see coming. It leads to new ideas that have impacts everywhere.
So this Blue Ghost mission and the success of the EDS could be really pivotal.
Oh, yeah.
Not just for the moon, but for any field dealing with these kinds of challenges.
It could change how we think about exploration and problem solving
Yeah.
in all sorts of tough environments.
It's definitely a mission to keep an eye on. And it reminds us that even something as simple as dust,
Yeah.
it can hold the key to all kinds of possibilities.
It's been great talking about this with you today. It's inspiring to see how we're taking on these challenges and opening up the future of exploration, not just on the moon, but beyond.
It really has been a fantastic discussion. Thank you so much for joining us on this deep dive into lunar dust and the electrodynamic dust shield.
Happy to be here.
And for everyone listening, we hope this has given you a new appreciation for the incredible work being done in space exploration. Remember, solutions for space often end up helping us right here on Earth too, so keep that curiosity going, keep asking questions, and never underestimate the power of even the smallest things, like lunar dust, to unlock amazing possibilities.